The third example here, there's a specific reason this example is here, and it's mostly about settings on a calculator. It says find tangent of 68 degrees to 3 decimal places. Well, 68 degrees is not an angle in one of our nice triangles. Remember, those are either 45 degrees with the isosceles right triangle or 30, 60, right? And 90, of course, in the other right triangle standard right triangle that we use a lot in examples. 68 degrees is not one of those. So really, the only way we can do this with methods that we have now, or even the rest of this semester, is just to put it on your calculator. Now there's two ways to do this. You can do it in degrees, but you have to make sure that the mode on your calculator is set to degrees. If it's set to radians, you'll get the wrong answer. Okay, so you can either set the mode to degrees, or you can convert this 68 degrees into radians and then use the mode on the calculator as radians. Now, in a calculus class, I usually recommend that everybody just leave their calculator on radians, so that because we use trig functions a lot and they'll mess it up. And because in that class we only use degrees if there's some kind of application problem like physics, or a geometric problem that's an application, like you have a tree and you're measuring an angle, situations like that is the only time when we use degrees. And most of the time when we're doing more abstract things, we use radians. Actually, with more abstract things, we always use radians in calculus because it works out better than degrees do for computations. However, in this course, with this particular textbook, they seem to do degrees and radians about equally often. So my suggestion for this class would just to be super careful about what mode you're in and make sure that you're in the right mode when you do these computations. And then really this is just a matter of putting it in the calculator. But the problem is here to point out that you need to set the mode correctly. Okay, so you need to set it to degrees. Now I actually did this by converting the degrees to radians just for practice, so I could show you, so you can see another example of that, even though you've practiced it before. So as a reminder. But you can, of course, just set the mode to degrees and then just do sine of 68, cosine of 68, tangent 68, etc. It asks for, well, actually, I'm sorry, it didn't ask for all of them. It just asked for tangent, so that's pretty simple. So I wrote out here how to do that. Let me back up a little here. My writing got way ahead of me here. So you set your calculator to degrees or to radians. So let's say we want to set it to degrees. We would go to the calculator, you press the mode key, and then you would select degrees or radians from the screen that comes up. You'll see there's a place where it says degrees or radians, and you just, select using your up and down, right, left arrows, and press enter on the one that you want. So let's say we're doing it in degrees, you just press enter on degrees. Now it's in degrees. Or if it was already in degrees, it'll be highlighted. And then you can just get out of that menu and then just, do tangent 68. Okay, so it's fairly straightforward. I just did this for fun. I converted it to degrees. It turns out fairly nice. It's a rational number anyway, times pi. 17/45. Integer degrees will always become rational coefficients of pi, multiples of pi. So in radians, tangent of 17/45 pi is approximately 2.475. Now, if I calculated this in degrees, as long as my mode was in degrees, so here I have my mode in radians, okay? If I did the mode in degrees and just use 68, I would get the same number. Okay. So you just have to make sure the mode in your calculator matches up with what you're doing. Okay, so you have to pay attention to whether it's radians or degrees. So if you have something where the angle, if you were converting angles and you had something where the angle is a multiple of pi over 4 or pi over 6 or pi over 12, after learning something called the difference identity, we can find multiples of pi over 12. Then we want to use exact answers. That's just an aside. In this case, you're not going to have an exact value for the tangent of the angle, even if you do for the angle. So you would still estimate it, and it said to estimate to 3 decimal places, so I rounded it off to 3 decimal places, about 2.475.